అందరికీ నమస్కారములు. శ్రీ గురుభ్యో నమః. శ్రీ మహాగణాధిపతయే నమః. Today is another good day for all of us, that we are going to have another session from Dr. Gautham Mukherjee garu on Vedic mathematics. We already had 3 sessions in the last week and revised whatever is taught in the basic course. Now we are on advanced course, level 2, certificate course on Sanatana Dharma. So in these 3 days, next 3 days, today, tomorrow, and day after, we will be learning new concepts like division and then remainder theorem, like this. So now let us start the session with Vande Mataram and Prarthana. Well, let us request Challa Chittibabu garu to recite Vande Mataram. All of us recite along with him.
Vande Mataram, Vande Mataram, Sujalam Sufalam, Malayajasitalam, Sasya Syamalam Mataram, Vande Mataram, Subrajosna Pulakitayamini, Pullakusumita Drumadala Shobhini, Suhasini, Sumadhura Bhashini, Sukhadam Varadam Mataram, Vande Mataram, Vande Mataram.
Vande Mataram. ధన్యవాదములండి చల్లా చిట్టిబాబు గారు. Now Anantanji, please chant Prarthana.
सर्वेभ्यः नमस्कारः. प्रथमतया एकनिमिष ध्यानं, 1 minute meditation. Let us close our eyes. Sit erect. Watch the breath. Visualize your surroundings. Visualize your body also. Don't entertain any thoughts. Make the mind to watch the breathe. गणानान्त्वा गणपतिगुं हवामहे कविं कवीनामुपमश्रवस्तमम् ज्येष्ठराजं ब्रह्मणां ब्रह्मणस्पत आनशृण्वन्नोतिभिः सीदसादनम् महागणपतये नमः। प्रणो देवी सरस्वती वाजेभिर्वाजिनीवती धीनामवित्यवतु वाग्देव्यै नमः। गुरुरेव गतिर्गुरुमेव भजे गुरुनैव सहास्मि नमो गुरवे न गुरोः परमं शिशुरस्मि गुरोः मतिरस्ति गुरौ मम पाहि गुरो ज्ञानानन्दमयं देवं निर्मलस्फटिकाकृतिम् आधारं सर्वविद्यानां हयग्रीवमुपास्महे श्रुतिस्मृतिपुराणानामालयं करुणालयं नमामि भगवत्पादशङ्करं लोकशङ्करं शङ्करं शङ्कराचार्यं केशवं बादरायणं सूत्रभाष्यकृतौ वन्दे भगवन्तौ पुनः पुनः ईश्वरो गुरुरात्मेति मूर्तिभेदविभागिने व्योमवद्व्याप्तदेहाय दक्षिणामूर्तये नमः। ॐ सहना भवतु सहनौ भुनक्तु सह वीर्यं करवावहै तेजस्विनावधीतमस्तु मा विद्विषावहै। ओम शांति शांति शांति। हरि ओम। सर्वेभ्यः नमस्कार।
ధన్యవాదములండి అనంతన్ గారు. Now let us request Gautham ji to continue the webinar, please.
सभी को नमस्कार। सभी को नमस्कार। Last when we did this division in the earlier methods, come back to that division page. We found that a case was there. I made it name longer complication. Suppose this is quite away from 1000. I mean, nearest 10 tens power. Then what happened? Once I divided, there was a big, huge remainder. Again, we start with remainder. That also divided. Again, it gave a very big remainder like this. I mean, this one. Sorry, this one, 5411. Again, I did 5411, and again it did 2141, and so on. It went on like that. So 5, 1, 2, 3, 4, and finally also this was bigger, and then we subtracted. We got that final remainder like this, and we had to add up all these. First 492 here, then 22 here, 5 here, 2 here, and 3 here. 5 here and 3 here. So there I mentioned that best Vedic method is state division for the above problem. Now let us see what is state division. So we completed all these like recurring decimal, this oscillation method. I did the revision of that. Now we come to the state division. The state division comes due to an algebraic background, which is actually based upon remainder theorem. Sometimes we'll teach remainder theorem also. Now let us learn the procedure. Suppose I have to divide 38982 by 73. What are the steps? First, we divide 37 by 7. We get quotient as 5. So 5 we put down here. This becomes my first digit of the result. The remainder becomes 3, and then 3 I put here, just a corner just below 3, below 9, the next digit. Next digit of after 38, next digit is 9. So with this 9 and that 3 remainder, we get a number 39. Now, so far we didn't act anything with the 3. Now, here the roll comes. Here we multiply with 3 by this first digit of the result. We get 15. That 15, we subtract this 39 to get 24. Initially, it may look quite complicated, but its logic is this, that when you are dividing this by this and getting the remainder, this particular number now have to be subtracted by this into this, means result of this unit digit of this with this first digit of the result. So we get a number 24. Again with 24, we divide by 7, means that first digit of the tens digit of the divisor. And quotient is 3 and gives second digit of the result. Put it down, it becomes both the quotient and remainder both become 3. 3 into 7 plus 3 is 24. And with the 8, it gives 38. From this, we again subtract this 3 into 3. Now, everything we are shifting or digit by digit. Actually, it is evaluation digit by digit like the same procedure. 3 into 3, and then we get 38 minus 9 is 29. We write here somewhere. And 29, when we again divide by 7, and then we get quotient and 4 and remainder 1, which 12 with 2 it becomes 12, and then from that we subtract 3 into 4 into 12, so it gives 0, and then also there is no further division, so my result is 530. That is the idea. It can be understood.
No, this how 39 has come is not clear.
Actually, after dividing this 38 by 7, we got 5 as quotient and 3 as remainder.
Right.
These 3 and 39 got 3 and 9 becomes 39. This 3
How
9.
does this 9 come?
9 is this we had given 38982 is the my
Okay.
We write here in this sparsed format. See, you have written 38982, 38982.
Right.
Okay. This is, I'm dividing this by this.
Sir, explain once again.
Once again, yes. Let's see. First, this by this I divide this, and I get quotient and remainder, Q and R. 5 into 7 plus 3 is 38. Okay. Now, what we get? We get 39. Now, now the roll up this comes. So far, we acted with this one only. We acted this first. We acted this one, and then the roll comes here. This I multiply with 5. 3 into 5 becomes 15, and 39 minus 15 is this becomes 24. See. Now, earlier we whatever action we did on 38, now same action we will do with 24. What is that? 24 divided by 7 now. Now, we did this 24 divided by 7. We get, what we get? 3 as quotient and 3 as remainder. Now with these 3, we act with these 3, and this becomes 38. But with these 3 plus these 3, when we multiply and subtract, my next dividend, small dividend becomes 39. 29. This 29 again we follow the same procedure. This is 29 we divide now. We get what? We get 4 into 7 plus 1. 1 as remainder. And this 1 and 2 becomes my 1 and 2 become my this 2 digits. I mean 12 becomes my next number, which has to be subtracted from subtracted by this 3 into 4, which is again 12. So this gives the 0. And with 0 and no more digit here left, so I declare this as a real. Let us take another similar example. Here, 55859, we write in this fashion, and 83. We are dividing 55859 with 83. So similarly we do, what should we do? 55 we divide by 8. That gives me 6 and 7 as remainder, 6 as quotient and 7 as remainder. 6 becomes my first digit of the result. Result quotient. So this 6, 7 and 67, 6 and 7. This 7 with the 8 with the next digit of this dividend becomes 78. And we again subtract this 3 into 6 is 18 and subtract this 78 and get 60. Now we follow the same procedure. We divide 60 by 8 and get 7 as quotient and 4 as remainder. And then with 4 and that next digit of the dividend, 5, it becomes 45. From that, we again, this 3 into 7 is 21. With 45, we subtract 21 to get 24. Now my focus gets shifted to 24. With this 8, 24, we get 3 as quotient and 0 as remainder. With that 0 as remainder, there is one more digit. So it becomes 09. And from that, we subtract the 3 into the next result. Earlier, always see with 3 into 6 we did and subtracted from 78. 3 into 7 we did and subtracted from 45. Now, from this 09, we subtract 3 into 3, which is 09, and get 0. And no more digit is left, and also it becomes 0. So there is 673 is the result. Okay.
Can we have one more example, please?
This one. 54288 divided by 72. Okay. 72. What should we do? First we divide 54 divided by 7. 7 into 7 is 49. 5 is left. His remainder. 49 first plus 5 is 54. With the 2 here we get 52 as my number. 52 we get back. But from that 52 we this 2 into 7 is 14. 14 and 52, we get 38. When I subtract 2 into 7, 14, from 5 to 52, it becomes 38. Now my focus is shifted to 38. 38 divided by 7, we get 5 as quotient and 3 as remainder. We make this becomes the second result. This is the one result and one next digit result. This 38 is formed. Then from this 38, I subtract 2 into 5. Earlier we subtracted 2 into 7 from 52. Now from 38 we subtract 2 into 5 to get 28. Now my focus is shifted to 28. 7 divided by 28, we get 4 as quotient and 0 as remainder. Now we get 08. From that 08, we subtract 2 into 4, which is 8 again. So it is 8 minus 8 is 0. And no more thing is there. So my 754 is my result. Clear? Maybe with this one, I let us do it ourselves. To repeat that thing ourselves. We write like this. Tell me what should I do first?
Huh. 38 divided by 7.
So 38 divided by 7. So you get 5 as the result. And you write 3 here. 39. From that, what we do? Now we multiply 5 into 3 is 15. 39 minus 15 is 24. (24 by 7). It becomes what? 3 and 3. From that, it becomes 38. From that 38, we have to subtract what?
3 into 3, 9.
3 into 3, 9. So if we subtract 9, what happens? How much is? 29. 29. Now the 29 we divide by 7. What we get? By 4 as a quotient and 1 as a remainder. 4 into 7 plus 1, 29. Now you get 12, and from that we subtract 3 into 4, it is 12. So it becomes 0. The result is 0. So 534 becomes my result. Okay.
I think we have to do it once again and so that to have the practice. Otherwise, we don't know where to write this 3, 3, 1, 24, 29, you know. That becomes a, yeah. I mean, anyway, otherwise it's clear.
Uh, One more example. I did 3 examples. Now, higher number of digits actually becomes more complicated. So, presently not. Let us get confined with 2 digit of divisor. That is, with 3 digit of divisor, again, imagine it will be even further complicated. So, yeah, it is just an alternative actually. When comes digits comes like arbitrary, as I told that conventional division we practice since childhood. There is no problem as such with that. But this is actually you handle digit by digit in a different format. You first we handle with the tens digit, and then sort of a cross kind of multiplication comes. With the from the remainder of the division of these to 10 digit, we are subtracting the first digit of result with the second digit of the divisor. So it is, well, this kind of cross subtraction is being done, and as a result, actually in the background there is a equation, and it comes from a remainder theorem maybe, and then it is actually it comes like that. That we have to do. And the second result also we do. Below slightly. What should I do first? What should I do
55,
first?
55 divided by 8.
8. And get what do you get quotient and remainder? Nine goes here. 9 into 8 is, 7 goes. 7 into 8 is 56. No, it doesn't go. So 6 goes. And 6 into 8 is 48. 55 minus 48 is 7. Isn't it? 7 is remainder. 6 is quotient and 7 is remainder. This is 78. Now from that we subtract what? From 78, we subtract what?
3, 6 are 18.
3 into 6, which is 18. So it becomes 60. Now, whatever you did with 55, so 55 also I can write here so that we have known that what we did with what. Initially, the same thing, same number we start with. Now, with 60, we do the same, similar things. What we did, 60 divided by 8 is
8 7s are
7. And then remainder remains
4.
4. Now it become 45. From that 45, we subtract what?
3 7s are 21.
3 7 are 21. And becomes 24. Now 24, this 24, what do we do?
8 4s are 32.
24 is divided by what?
8, sir.
8. 8.
8 3, sir. 8 3 is 24.
8 3 is 24. And remainder?
0.
No remainder? 0.
0.
Now we get 0 9. Means 9. From that we subtract.
3 3 is 9.
3 3 is 9. It becomes 0. So my end here.
Number 7.
Now suppose, let us see, it happened to, let's see what, okay. Now let us have this practice. After that we'll see, maybe tomorrow we'll slightly modify these things. Okay. Actually, there are certain complications. It comes here, I tell you. Sometimes, or whatever actually is coming directly, we may not take that, because sometimes it happens that other result comes. Some negative results may come and so on. From and in that thing, in that case, so some expertise is there with this past. Then only you can play with that, and with the we have to then choose the previous digit. Whenever negative something comes, we have to choose the previous one so that it becomes positive, and then we work with that. So there is the algebraic background also on that. Why we do it like that? Here we have purposefully taken 3 examples where it is very easy. Actually, it's straightforward. So this also we do. What do we do first? What do you do first? 54
by 7.
And then result is
7
7
and 5.
5. Now there is 52 here, right somewhere here 52. But from that we subtract
14.
2 into 4,
7,
14.
14. 38.
It becomes 38, no? From the 38, if we, what do we do next?
7 5s are 35.
7 5 is 53. 5 and
3 remainder.
3 remainder. It becomes 38. From that, we what we do? Subtract what?
2 5 are 10.
From that, we subtract this again, the second digit, then second digit of dividend comes into play. 2 into 5 becomes 10, which is 28. I write 28.
18 remainder.
Then
18 remainder. 1 8.
28 we do what?
With 7, 4 times.
So, result becomes
7 5 4.
4. 4 and it becomes 0 here. No remainder. And from that 8, 0 it is 8, subtract again 2 into 4, 8. So it matches. So 754 becomes my result.
Just tell here as to how we write these things, because when we are writing, we may have, there could be a, this, for example, first we write 5 4 2 8 8. Then we have this 7, we divide. So this 7 directly we write in the bottom. And then 7, the next is 2 7 7s are 14, and we deduct from 52. And then remainder we write above this 2 by the side. I mean, this is
actually in the
how
book
we
it is
write.
not written. It is actually one has to just it keeps in memory.
Okay.
Despite it becomes you need not write in the above. It is just we are learning, so we are writing. So expert people write memorize it. Then again becomes 38. So you divide by 7. So they write 5 only, not the 38. They do not write. They write 5 and 3. 5 into 7 plus 3 is 38. After that you write, then again you subtract 10, becomes 28. So 28 do not write. 28 7 by 4 by 7 is 4. This looks like that. So whatever I have written on the top, it is these are not written, not required. This will be in the memory. Only you have to write like this. Oh, sorry. Whatever comes below, the 7 and 2 will be writing, of course. This will write and this we'll write this because these are the things, and we'll write the result. This top line is not required to be written. Top line is not written. It is that how much time? Now let us see whether we can. I could give one example only. Vargamula, square root. 119716. Achha, first let us discuss 119716. What kind of Vargamula I have we have learned already? Can you revise that?
No, we have not read about square roots at all.
Huh?
We didn't read about square roots. It was not done. This is the first time we are Learning about
No,
square
in the
root.
school and so on.
Oh, okay,
Huh?
okay. Uh-huh. In the school, yes.
What is that? What did you do to just recapitulate that?
Oh, very difficult.
As far as let me also remember, okay. So what we do, group from the right, because square root. So each of them will be having group, as if each digit becomes a multiplication of 2 digits. So it is a group like that. And first we did what? So you see that how much is the square root or nearest square root that. So we do 2 into 2, 4, 3 into 3, 9, 4 into 4 is 16. 16 becomes above that. So 3 is below that. Okay. So 3 3s are 9. Nine, and then becomes 2 into 97. Okay. 2 into 97, 297. Now you have to do something with double of that, means 6. I mean, double of this, which is 6. Now with this 6, I have to find a digit where same digits fits. Say 61 into 1. 61. 62 into 2. 124. To come near to that. 63 into 3. 189. 64 into 4. 256. But we get, so you come near to, easily you can find the 6 comes near 4, and you have to only check that whether this next digit actually comes to that. So it's 64 into 4 is 256. So 1 and 4. The 4116. Okay. Now you remember, some of you remember what was the step?
34 into 2.
Huh?
34 into 2. 68. Isn't it? You have to double.
Sixty-four into
2.
Two.
34 into 2, 68. Is it 64 or 34? Which one you have to take?
34
to
into
double.
2, 34 2 into 68.
Ah,
68. Then 68, what you did? The next digit is chosen. So you have to double up 34, not 64. Because you have 6 is already obtained by doubling 3. So if we double 64, it will be again, it becomes 4 times of the 3, no? So actually you have to double this 34. So it becomes 68. Now you have to choose a digit by which this matches actually. So how much is coming near to that? 7 into 6 is above this 41. So we will start with 6. Let us see whether 6 also becomes, when you multiply 686, that means the same digit you have to put here as well as here. So 686 into 6 it becomes. So whether you have to, then you have to check 6 into 6 is below 41, but 686, whether 686 into 6 is below this one or not, you have to see. Now it comes that actually it comes to, it matches actually. 6 into 6, 6 and then 8, 51, 6 into 6 plus 5 is 40. So it becomes actually 4116. So if we put here, you put 6 here, and then you put 6 here, multiply this 6 with this and becomes 4116. Clear? We did like that?
Yes, now I remember.
Actually, we may not have all the time very much practice with square root. So normally we have ignored these things. And we did for very long, less time. Compared to what I'm telling, compared to multiplication, division we did throughout our life, we didn't do that much of this square root. So if we revise from the beginning, we group from the right, and then 11 comes here. In the 3 into 3 is 9. We subtract, it becomes 2, and then we drop down 2 at a time. In case of normal division, we drop 1 at a time, but here it is 2 at a time we have to drop. So it becomes 297. We have to choose a digit, and we double that 3 to 6. The result is double to 6 here. And we have to choose a digit so that it comes near to that. Same digit here and here. So 4 into 64 becomes 256. And subtract from this 297, so it becomes 41. Again, two digits are dropped, 16. And then it becomes 34 into 2 is 68. 34 into 2 is 68. And again, we did a digit, same digit, both sides. So when you multiply with this 6 here, 6 into 686, it becomes 4116. It matches here 0. So this is my result. Now, here what we are doing. Steps. Group digits up to from right. We did the same thing. See here, 119716. But in a different format. And 11 we take as a my this thing. No, to the starting point of working with. And similarly, we do square root of 11, which gives 3 here. And double of that we put here, 6. But now, sorry, what I'm doing, here 2 remains. Means 3 into 3 is 11, 3 into 3 is 9. 11 minus 9 is 2. That 2 actually becomes important. Actually, it has some similarity to set division in writing this format like this. This 29. Now, 29 is divided by 6 with the double of that double we had already kept here. With this double, there are some more work with this. So 29 we divide by 6, it gives 4. And this becomes my second digit of my result. And remainder is 5. With this 5 with the 7, with the another next digit of this thing. Now we are handling one by one digit by one digit, but grouping was done to get this 11. Grouping from right was done to get this particular numbers to start with. Now with 57, what we did, square up this 4, we subtract, we get 41. And 41 again, we divide by 6, we get quotient and 6, and then quotient and 6, and remainder as 5. Remainder quotient as 6 and remainder as 5. It becomes 51. Now comes a tricky thing. Actually, it comes from the algebraic expression. We subtract this 51. From 51, we subtract 2 times this 4. The 2 times of this 3, this 6 is 2 times of this 3. And now 2 times of this 4 into 6 is 48. We subtract from 51. We get only 3. And 3, when we divide by 6, we get 0 as quotient and 3 as remainder. With this 36, from that we subtract the square of this 6, not that, this 6, and it becomes 0. It matches. And no more digits are left. (36 minus 36 becomes 0, and 346 becomes my result. It looks more complicated, no?
Yeah, but then we had 34600, and you have removed the 2 zeros.
Because actually it comes as a decimal point.
Okay.
Comes as a decimal point.
Maybe one more example, I think.
One more example.
Or you explain the same thing again, maybe people will understand. Yeah, I think explain once again.
1 second. I'll see actually what is happening in the background. This expression, okay. What happens here? It becomes 6 terms, no? What is that? A square x to the power 4 square x square plus C square. Please tell me. These are the square terms and there are cross terms. Okay.
Plus 2a x square b bx.
First, let us see AB. 2AB x cube
X cube.
plus
Plus
2BC
2bc x square x
2BC x
x plus 2ac x square
2AC
x square.
Somebody please note down on a piece of paper. Now, let us put the terms of x square, power of x from the left to right. Now, x to the power 4. It is x square, a square, x to the power 4. Plus x cube. How much x cube are there? Only one x cube. 2AB x cube. Plus how much x square are there?
X square only one. 2ac x square.
2AC
B square, X square, and AC X square.
plus B square. X square. Okay. And how many x's are there?
One.
One x. And without x, constant term is also 1,
C square.
which is C square. Now see, in this straight division, straight square root, what we did, we first took out this term. Imagine now that instead of x, we have, it is 10. It is 10. So this gives my unit digit, C square gives my unit digit. This 10 is there. So 2BC is my 10th digit. Of course, if C square has some carry, it will also contribute here. But we are not presently doing it, considering it. So 2B it becomes my 10 digits. This becomes my 100 digits. X is 10. But again, some carry will be coming from right. 2AC plus B square. And 2AB, this becomes my 1000 digits, it becomes my 10,000 digits. Leftmost digit. Now, first what we did, I remember that what 11 something we did 3 into 3, 9. So A is equal to 3, A is equal to 3, it became like that. We detected that A is 3 there. Now we double that. We kept 6 there. So you remember with that 6, we acted twice. This 2A and this 2A. This 2A actually is 6 that we wrote in the extreme left. Now from the x cube, when we next digit we divided, there is a quotient. That quotient was this B, and with remainder we mixed up this one. From that we subtracted this, B, we took it down. The next digit was there, suppose B was there something. From that we divided, subtracted the square to get that, this number, to get that C. To get that C, we had to subtract the square of that number. So I explained the background, these kind of things. So, and then with 2A already we did, but after that we got a result, and there somewhere you said 2 into this B into another digit there was there. We subtracted, you remember? 2 into 4 into 6 or something like that. So this is this 2BC term. And finally we subtracted this square and it matches 0. So that term by term, we are evaluating that. Basically, this expression you write somewhere, all of you, please. This below. A square x to the power 4, 2ab x cube plus 2ac plus b square whole x square plus 2bc x plus c square. Wrote it down, all of you? Okay. So I also keep it handy so that now you go back and see what we are doing. So 11, 9, 7, 1, 6. Now these are the those results. So basically it is 11 x square x to the power 4 mixed here. Now we have to find out this 11 is basically my, this is the x 1 is x, 7 is x square, 9 is x cube, whole thing is x cube, and 11 is x to the power 4. But it actually contains carry of the lower term as well. So when we have to filter it out, the actual real x to the power 4 have to real that x to the power 4, from that we have to filter out what is a. So that is the, when we just square it, nearest square, nearest square 9. So 3 becomes my first digit of that. So that becomes my a. Now the 6 is twice a. Now I have to find out the b now. Find out the b. How to find out the b? We with this 2 as a remainder, the 2 into this 2, 29. So this actually became the carry. This was the carry of the previous from x cube term. So 29, 2 was the carry. So from that we subtract, divide this 29 by 6. So to get 4, 4 becomes my b. If this term is the dual term, and from that we subtract. No, this becomes my x cube term. So but it gave a carry towards the next term, which is 2ac plus b square. Okay. So from it becomes 57. From that, when we subtract the b square, so we get the pure term of 2ac. See, 41. 41 contains 2ac. plus of course carry from the next one. So this becomes actually, you can logically establish it. From this large term of the expression, you can logically turn. I will again explain the procedure first, then I will again do it. What we did, please tell me. 11 square root you did. So it becomes 3, it becomes my result, and 2 becomes my remainder. This 2 is the mixed with 9 becomes 29. 29 we divide by 6 to get 4 as my quotient, and that becomes my result of this second digit, and 5 as remainder. With 5 and 7 becomes 57. From that, we subtract square of the b square, we subtract. Square of this 4. Square of this 4 is subtract. 57 minus I have written somewhere. Yeah. 57 minus 16 is 41. This 41 I write here. Forty-one we divide by 6 now. So again there is one more term of this 2a is there. 2a is 2a. 2a was once used here when we divide 29. Again we divide 41 by 6, so because 2a part is over now. We get the result 6 and we 5 as remainder. This becomes 51. But from the 51, so it contains the part of the carry of the next one. So from 51 is subtracted what? You have wrote down the next term. There is a 2 BCX, isn't it? You understand wherever you note down the equation, 2 BCX. That 2 BC X is actually here 10. So from the 51, we subtracted 2 BC. This 2 into 4 into 6. This is my A. This is this 3 is my A. This is my B, and this is my C. So 2 BC is subtracted from this 51 to get only 3. With 3 and the next digit becomes 36. This signifies the this square, C square. So this becomes that 6 square is 36, so C must be 6. And we matches it and it becomes 0, and the process is over. So what some more example will be required for this. Now let me should we do one more example?
Yes. Instead of taking big numbers, can we start with some small numbers like 25 or 36 or some 3-digit numbers instead of these big numbers, so that we can slowly move forward?
Oh, 2-digit number.
Or 3-digit, I mean, the simple numbers, so that we can slowly move to the big numbers.
Mm-hmm. This was the favorite number of my father, who taught me this fast name, square root. Let's see first conventional method. After that, we will go for this method. What is that? We did 2 into 2, isn't it? And we did 4. And we told that is 5 and 5. You put 5, this becomes 225. Matches? So this was the conventional method. Now let us see. Grouping from the right, it takes that 6 becomes the my things to do. So we did with 2. We write 2 here and 4 here. So when we work with this 4, what we did? 2 into 2 is 4. This 4 is different. Twice of that 2, but the square of this 2 is 4. We subtract this, remainder becomes 2. So it becomes 22. From the 22, what we did? 4. 5 quotient and 2 remainder. So we put down the 5. 5 quotient, so immediately we put down 5. What should I do then? 2 remainder. This 2 remainder becomes here. Okay? Isn't it? We did like that. From the 25, we subtract. Now there is only 2 terms. There is no 2 into BC kind of term is not there. Only this term is there. So 25 minus square of this means 25. This 25 is this one. This one is 25. 25 minus 5 into 5. Square of the second digit. Roll of 4 is doesn't come here anymore because there is only one term. A square plus 2ab 2ab plus b square. So we have already worked with 2a already here when we did this. So 5 into 5 becomes 25, which is 0. Sorry, this 25 we subtract by this and then becomes 0. And no more digit, so 25 is my answer. Like that, like this you have to do. Anyone does any other square? You can do it then. Any other example? Let us see another.
225.
Huh?
225.
225. So grouping from right, imaginary group we can do, and then 2 comes here. So 1 into 1 becomes 2, and then twice of that 1 we write here. 1 into 1, 2, and this it comes. Sorry, 1 into 1 is 1. 1 into 1 is 1, and then 1 remains as my remainder. This makes it 12. From that, what we do? And here it actually, also book also challenge may come. Here it is looking as if when you
Yeah.
divide this 12 by 2, it becomes 6.
Yeah. Yes, yes.
And 6
So now
and
we have
0.
to take 125, we have to take. If we take 125, no, I don't know. 225.
2 is 15 square, we know.
Yeah, yeah.
15 square in a case. Okay. Now, what is happening? Here actually, we have to take
Okay, we take some other example instead of this
Uh-huh.
complication.
another example. This actually is, as I told, this is, we cannot choose, this becomes something becomes negative and then we cannot work with that anymore. 520. So you do not know at all this one. Again, by grouping this thing, 5 is left. We did 2 into 2. 4 is there. And 2 into 2, 5 minus 2 into 2, 1 remainder comes. Okay. Now, when you divide 12 by 4, 3 becomes my result and 0 becomes my quotient. Now, from this 0.9, we subtract 3 into 3, which is 9. So 9, it becomes 0. So there is no more digit. So 23 is my result. Now it is coming gradually easier, no? Only though that challenge you to those some discrepancies are there in this method. Whereas 225, you could do conventional method, it was not problematic. Conventional method, it was straight away. 1 into 1, 1 here, 125. It was 2 here, 5 into 25, 5 into 25. 5 into 25 becomes 125. Conventional method was very straightforward. But there actually some consideration has to be there. 529 was nice in this. Another one, let us see. 349. You tell me? What will be my starting point? Babuji?
Just a minute. Babu Garu, people want to be unmuted so that they can talk.
Yeah, yeah.
Yeah, I think Colonel Babu Garu, you can kindly do the next.
All are
Yeah.
unmuted only.
I think, but they're asking question to we. Put in
What is the
chat.
starting point? With what we start?
Yeah, first we group.
From the beginning, from the end, from the right, so 49 to 32. So we work with 32.
Now
No.
all are unmuted. Just try it out. All of you can try.
What is the first step? What we do with 32? What we do with 32? This is the question.
7 into 7.
5, 5,
5, 5, 20. Then what do we do?
7
Something right in the left.
double 10.
10.
7 remainder.
7 remainder.
74.
74. What do you do with 74?
74 divided by 10.
Divided by 10. So what is the quotient?
Quotient will be 7.
And remainder?
4.
Where do you write it?
4. Below 9.
Below 9. Somewhat left below 9.
Somewhat, yes.
So this becomes 49.
49. 49. Square of 7.
Square of 7. So what do you do with that? We
49. 49 minus 49, 0.
we subtract this square of 7. Becomes 0. And no more digit is there. So 57 becomes my answer. One more. Like it. What should I do?
Grouping two digits from right side.
Then you have to first start with working with what?
1.
1, isn't it?
1.
So what do you do? Square root.
1. 1. 1. 1.
And what do you write in the left?
1.
1.
2 is it.
2. 2. 2.
Now 1 into 1 matches. It is 0. We did work with 6. So again here also that same problem comes. Because you know there is somehow. So it will actually to this little advanced thing we will do it, maybe do it tomorrow. Actually, it prompts that the 2 divided by 6 is actually 3. So this actually put it towards next one will be negative. Or let us see what we do. We do it 2. Okay. Now 2 into 2 is 4. And this 2 is remaining. Actually, it becomes a little complicated. We'll do it next time. If the time permits, let us easier one we do first, and then we'll go for that. 4096.
We are just having 5 minutes, so just have a look.
This one can be done.
Right.
Please tell me what is first step.
6, 6, 36.
6 is a 36. And who is right in the left?
12.
12.
So
4
6 is
remainder.
the 36, 4.
4 remainder.
4 remainder. This become, make it 49.
49.
From this, what we subtract? I mean, what we do with 49?
Square
Divided by
root
12.
of 7.
We quotient, isn't it?
Divided
Not,
by 12.
do not do in minus. We divided by, divide
False.
by. It's not minus. So just 4 has come. 49 is divided by 12.
12.
49 is divided by 12. So
12 fours are 48.
48 and remainder
1.
1.
16. From the 16, what we do?
4 square root of 4.
No, not 16 square root I'm interested. I'm
4
subtracting 4 square.
4 square root.
16. Square root, 4 square.
Yeah,
4
4
square of
square.
4. So it is 16.
16 minus 16, 0.
0. So this becomes my result. It matches. So no more digit. It becomes 54 from. Okay.
We can take questions now because it's 8 o'clock.
Yeah. So whenever you have 3-digit square root, we always have that consideration of this term. It is coming from that 2 BC. In conventional method also, because this conventional method also, when we do it, say 34, it came to 34 and we did double of 34 and did something. We actually did in the background, this kind of thing. Somewhere actually those equations it always comes in the background. Any question? What did you learn from this state division? Or from anywhere in the revision somewhere? Any question? Anyone went through this algebraic deduction of the multiplex oscillator method? This one? How it comes? Even in a block of n numbers. We did this one, no? This one. So we had blocks of these numbers. We were subtracting a divisibility from 299. We did grouping in groups of 2. Why the groups of 2 come and so on? What is the procedures? The 69 we multiply with 5 and added with the rest of the thing. This comes from this particular thing. Anybody went through this algebraic deduction?
I think people are, including me, are afraid of algebra.
Oh,
So
yeah, it happens.
the practical
Yeah, because
application,
they
maybe
need to
people are
practice,
doing it. Yeah.
But the algebra is deduced so that this
Yeah,
this multiple oscillator is justified. Can be justified with the algebra. Now, did you go through this one? How
the
it is happening?
example, yes. The example, I could follow. Others maybe, I don't know, they'll have to answer.
Vedic mathematics appears to be more difficult than conventional traditional methods, sir.
But traditional method, how you do the divisibility test of this one, for example? Suppose let us take divisibility, how it you can test easily. What you otherwise when instead of apart from direct division, how do you test that whether this is divisible by 7 or not, 7,001 or not? How do you do that?
Crude methods are trying, finding out whether possible or not, and alternative things going.
I think this is not easy. Actually, this actually collapses it very fast. 597. See, group by 3.
Yeah, though this method of Vedic math of divisibility is very easy, difficult to follow, no doubt. But then the practical application of divisibility compared to multiplication and division is far less. So people basically can't understand where this divisibility is really coming into the practical maths. We deal with math, addition, multiplication, division, and subtraction. These are the common things that we normally deal with. So divisibility is something which we normally don't deal.
Yeah, in the school level, we are taught about
Yes.
even number and
Right.
2, 4, 5, small things, 6, 7. 7 was not taught. 7 was never taught. You'll find that divisibility by 7 was not taught.
Yeah.
Because this 7 requires this kind of consideration. You are right. Also, the divisibility maybe in
only people who are interested in maths and then pursuing something.
Some kind of physics where certain things are dealt with, where the divisibility, something is fitting with whether or not.
Yeah.
And suppose you have to feed some n number of things, blocks in a suppose it is 7 inches long is there, you have to fit it somewhere, you see that whether it is divisible by 7.
Oh, yes.
How many blocks go there, whether
Right.
that number actually integer number of that goes inside that. All these things sometimes may require it.
Right.
You are designing some machine where something has some measurement, whether it is actually this measurement is fitting there or not. That is
Yes, in engineering applications it comes.
Yeah. But here it actually in the recurring decimal, finding recurring decimal actually becomes a lot of mathematical properties. People sometimes discuss about these things. These 58 set of numbers is actually circular number, it is called. When you multiply it by 2, see it started with 0 here. Suppose 0.016 and so on. Sorry, 0.169 and so on. If you multiply it by 2, you'll find that it shifts. Multiply by 2, somewhere you'll find that 32 and so on is there. 33 is there. See, 338, 49, then 90, 49 and then 98. There is a 15. There is 49. So when you multiply whole thing by 2, you'll find that it comes to that 15 into this. 25 into 2 is 50. 42 into 2 is 84. 37. See, and people get interested. People say it is mathematical magic. 28 doesn't become 56, but 57 because there is some carry. 81 has carry. 162, and this one actually mixed up here. So people get interested. We multiply by 2, it comes back. Like these are the very people do play with this mathematical game often, but the background is like this because of this recurring decimal properties. You have seen that people. So, do you hear me?
Yeah.
People play with these numbers 1, 4, 2, 8, 5, 7, and say that if you multiply it by 2, what happens? Multiply by 3, what happens? It comes back within these things. So this proofs anybody followed? How it is coming?
Yeah, I think today the time is over, right?
Time is over,
Past 8 o'clock.
Okay.
Yeah.
Thank you.
Yeah, thank you.
Anybody followed this one? The repeated
1, 4, 2,
numbers
8,
of this
5.
thing? Okay. Tomorrow we'll see again. I will practice with that square root.
Right, thank you.
Thank you.
Okay. Thank you so much.
Thank you, Mukherjee. Thank you.
So could somebody learn nicely that at least some part the state division as square root, Vargamala?
Thank you very much, Gautham sir.
Namaskar. Thank you.
Namaskar.
Welcome.
Okay.
It's very quickly, it's
Sir,
very
could not
simple.
follow, sir.
but,
Tomorrow, can you explain
yeah,
once
conventional.
again?
It is better to give homework.
Homework.
Simple Vargamol.
Simple Vargamala. Let us.
Okay, give it in the group.
Okay.
Uh,
Well, give it in the group.
Give it WhatsApp group.
Yeah.
WhatsApp group. You send it to me.
Thank
I'll
you,
put-
Mukherjee. Sir,
No.
Anantanji.
very interesting.
Thank you, sir.
But
Thank you so much, sir.
I can't follow fastly.
ॐ स्वस्ति प्रजाभ्यः परिपालयन्तां न्याय्येन मार्गेण महिं महिषाः गोब्राह्मणेभ्यः शुभमस्तु नित्यं लोकाः समस्ताः सुखिनो भवन्तु काले वर्षतु पर्जन्यः पृथिवी सस्यशालिनी देशोऽयं क्षोभरहितः ब्राह्मणाः सन्तु निर्भयाः अपुत्राः पुत्रिणः सन्तु पौत्रिणः अदनाः सदनाः सन्तु जीवन्तु शरदां शतम् ॐ सर्वे भवन्तु सुखिनः सर्वे सन्तु निरामयाः सर्वे भद्राणि पश्यन्तु मा कश्चित् दुःखभाग् भवेत् असतो मा सद्गमय तमसो मा ज्योतिर्गमय मृत्योर्मा अमृतङ्गमय ॐ शान्तिः ॐ पूर्णमदः पूर्णमिदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते ॐ शान्तिः हरिः ॐ सर्वेभ्यः नमस्कारः
ధన్యవాదములండి అనంతన్ గారు. Now let us request Chala Chittibabu garu to recite Janaganamana.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे जय हिंद जय हिंद
Jai Hind. Thank you, Andy.